What's up, everybody? Underscore green on Twitter. Still getting used to this whole streaming thing, so bear with me. But today, I'm pretty much gonna go through the Learn Python on AWS workshop. I found this workshop on the list of all the different types of AWS workshops, and I thought it'd be pretty cool to go through. So on the screen here, I have the workshop, which I'll leave a link to in the description of the video. But then also down here, probably gonna try to take some notes while I'm going through the different material. And then on the left here, uh, we have a Cloud9 IDE. So I just spun this up for this specific workshop, and comes preloaded with a ton of tools that are required, including Python, right? So, and a lot of the IAM credentials under the hood to perform some of the different functions that we'll end up using. Um, so yeah, with that, we'll just sort of dive right in. I've already, you know, done this step here with creating an environment in Cloud9. Um, yeah, so we can double check the Python version. Looks like we have a Python 3.6.10, which looks correct. Let's see here. Interactive Python environment, right? That's where we're at now. Can create this great tool for testing Python commands. Try now using an example. Type or copy the following into the Python interactive environment. So yeah, maybe a little bit more background. I'm pretty familiar with Python. Used it on different things, I guess. But never hurts to go back to the fundamentals and learn something new that I might have missed in the first time I started learning Python. So I'm familiar with this being like a variable. So some string equals, and then strings are usually in quotes. And then using like the print function to output the variable. Yep, so that's what we got there. Yeah, exit. I always forget that there's the parentheses are required. Cool. Virtual environments. Pretty familiar with virtual environments. I was burned before with installing Python packages on my globally on my machine, and there were dependencies that caused my computer to just sort of get really confused with what is where. So virtual environments are more isolated, and that you install the packages that are required inside of that virtual environment, and it keeps everything within that environment itself. So very, very useful when using Python. So let's go ahead and create a Python virtual environment, and then we need to activate it. Oops. So now you can see that we're in the this, which is great. Yeah. So there's other for Windows as well. Cool. So stepping into variables, like I said, I'm pretty familiar with it, but let's just go through what variables are. They're a value that can change. They can be used to store information that can be referenced and used by programs. Instead of using the stored value directly, we can use the variable instead. Variables could be any number of strings, such as a string of text, a list, or an object. Variable names are defined when you declare them. There's a style guide for like how you basically create or set a variable name. Like it says here, yeah, they should be lowercase with words separated by underscores as necessary to improve readability. I think that's actually called like snake case, right? Maybe. All right, cool. So here are just some examples. Yeah, so saving like a string variable, a float variable, an integer, the different data types, which looks like we'll cover in the next module. But yeah, so uh, data types, very important. That last example sort of showed some of the different data types, but um, let's see. The computer needs to know whether a variable is a string or a number or any other type of data. This is to prevent mistakes like attempting to add a string, which is Alice, to a number 5. Um, yeah, so uh, I guess it starts. So string is the first basically data type that we're going through here, and yeah, I've seen different examples of using double quotes for a string as well as single quotes. Um, but yeah, and then here it basically shows how you would use like double quotes within single quotes for a string. Um, okay, so this allows you the flexibility to use single quotes to wrap the string and double quotes inside of the string for a direct quote without Python getting confused. Yeah, so this example we can concatenate. Let me just move this up actually, and then we'll write clear. This basically shows creating two different strings and then concatenating them together, which basically brings them together. So first name equals Monty. Oh, so we're not in the REPL here. So okay, so now we'll try first name equals Monty. Last name equals Python. Right? And then if we print both of those together, first name, can't type today, plus last name, we get Monty Python. End of the word, or add it as a separate string. So you can either we can either modify these different variables to include a space, at the end here or at the beginning of this one. But like the example shows here, we can just press the up button and then add uh, just an empty string with, or yeah, a string with an empty space, to also like concatenate the empty space as well. So if you hit enter there, now we have a space between the two variables. Yeah, formatting. Using variables in strings. I've seen this before, but I think there's also, yeah. So same kind of concept, I guess, but you set the the values of these variables, and then you can print these out with this format method. Yeah, here, but they have f strings as well, which are fairly new within version 3.6. But basically the same thing without that format method at the end. This looks a little bit cleaner to me because you just specify the f string here, and then you're using those variable names within the string. So it looks a little bit cleaner in my opinion. So like if we were to type in print f, my first name is, and then brackets, first name, and my last name is, last name. That should give us, my first name is Monty and my last name is Python, I believe. Yeah. So I kind of like using it within the string like that. Using f strings just looks more readable and cleaner, in my opinion. What does this button do? New lines and indentation. So you can use the \n for a new line, and a \t for so I guess, yeah, I mean, for the first sort of, I gotta remember to take some notes here. So I guess this would be like data types, right? And if we say like, we'll just say this is like strings. What's something useful that we learned here? Like you can use double or single quotes. You can concatenate strings together. It seems like it's useful to know. Let's see. F strings use the value of a variable in the middle of a string. Wonder if I could, what it looks like if I add a, doesn't look too bad, I guess. I wonder if I could like shift this over. That's not too bad. And let's see what else. New lines and indentation. Yeah. The \n tells Python to put the text on the next line. Oops. The \t tells Python to add a tab spacing. It's pretty good for now, I guess. All right, moving on. Let's go to numbers. So an integer is a whole number, such as 50. The data type integer is abbreviated to int. Floating point numbers, just decimal point numbers with decimal points. Pretty straightforward. Yeah. Okay, so in the previous one we concatenated two strings together, but now it looks like we're gonna try to concatenate an integer with a string. Yeah, and from previous experience, I know that this won't work, but let's just try to go through that. So let me exit here and then clear, and then now we can type, we'll go back in and say my int equals 50, sentence equals the total comes to, and then if we tried, again to concatenate sentence plus my int, we get an error because my int here is not a string, it's an integer. So I think it shows to fix that, we have to convert the integer into a string. Oops. And yeah, you can use this str method to convert the variable from an integer to a string. And that's pretty useful. So if I just up arrow and then type in str, add that, now we get the output here because we converted that integer data type into a string. Yeah, so I think that's probably like worth noting here, I guess, right? So numbers, oops. It's not like perfectly aligned, but whatever. So numbers, what's something good to take away from here? pretty. I don't think I need to note that an integer is a whole number or a floating point is a number with a decimal point. It's pretty obvious, I think. But yeah, maybe making a note of these different methods, maybe like uh, you can use the str method to convert a variable from an integer to a string. So like, maybe just type an example would be print sentence plus str method my int, something like that. Cool. All right, what's next? Dictionaries. That looks wrong. Dictionary is a way of storing related information in key value pairs. It uses a key as an identifier and a value to store the information. For example, the key could be first name and the value could be Ada. Yeah, so I guess the important thing about dictionaries is, it stores these key value pairs. Dictionaries are very common in AWS, so you will see them frequently. They are used to exchange information between different services and functions. They are returned by APIs. They are used as tag values. Yep, that's right. Yeah, I think of dictionaries and like JSON, right? JSON is a bunch of just key value pairs. So creating, reading, updating, and deleting values in a dictionary. So let me just exit here, and then so if we assign user equals bracket first name, get the response back as a key value. You can create an empty dictionary. I've seen that used a few times, this syntax here, so that you can sort of like iterate on different data and then fill in this like empty dictionary. I've seen that before. To read the values associated with a key, you need to provide the name of the dictionary. So you can say print user and then specify the key of it, I guess. So if we add first name, oops, we get Ada. Dictionaries are immutable. I think that's sort of worth like noting here. Like, it's important to know that dictionaries are mutable and they can be changed. So we can just add. Interesting. Okay, so we can add user. So this is a different key name, family name, and we're giving it a different value. So Byron. So now we have two different key value pairs, and they're separated by a comma. We can modify that. So instead of saying Byron, we can say Lovelace. Oops. And then print that. So went from Byron to Lovelace now. We can delete key value pairs. So delete user. So we're completely deleting this key value pair. We should end up back at the original. A dictionary, like a variable, can contain other data types, including other dictionaries and lists. You will use dictionaries a lot in AWS as input and output. Cool. Really many other notes to add to that. It's pretty straightforward in my opinion. So now moving on to lists. Let's see what we can add for a list. Lists. A list is an ordered sequence of values separated by spaces. For example, there's a list of integers or a list of strings. You can have a list of dictionaries. I don't know why it keeps doing that. Okay. Exit. And that's clear. So let's go with Python. Let's create a list of fruits. Yeah, again, you can create these empty lists and then iterate, do like for loops, which I'm sure we'll cover later, to iterate through like different data and then fill in a list so that's easier to sort of get what you want. So reading an object from a list is given index starting at 0. So that's pretty important to remember. Can't say how many times I've like tried to search through a list and been there's a reason why they have that saying is like off by one, right? Because uh, oftentimes you forget that the index starts at 0 instead of 1. So if you're trying to look for oranges, you'd think that this would, when you're trying to look it up, you would think that this would be index 2, right? Because 1 would be apples and 2 would be oranges, but it's actually apples is index 0 and oranges is index 1, which is shown here by searching or reading the different objects in the list, and specifying which index they are that that object is located. So in this example, they're able to find oranges. This length method is pretty cool. You can see how many different objects are in the list. That's cool. You can work backwards from the last item using the negative index value. That's cool. Lists are also mutable, like dictionaries, which means they can be changed after you create them. So I'm gonna write that down too. So we can add additional like item elements to a list. I call them objects. I guess they're called elements. Using this append method here. So if I say fruit dot append kiwi, and then if we print, I haven't printed fruit yet. Now we've added kiwi to the end of the list here. If you want to add an element at a specific point in the list, you can use the index value with the insert method. So append will add the element to the end of the list, but if we wanted to add a fruit like looks like after oranges but before bananas, we can run this command here. So I'm just gonna copy this actually. If we print fruit again, now we can see that we've added passion fruit. I think that's pretty good to know. Like when it says sorted, I'm assuming that means alphabetically. So yeah, I wonder if there's other different types of different ways of being able to sort the list. But yeah, if we say print sorted fruit, let's make sure that, yeah, it looks like it's in alphabetical order. Oh, if you want to permanently sort the list, you can use the sort method. Interesting. I'm going to make a note of that. a lot of different methods that we can use on a list. Seems like here's reverse. This will permanently reverse the order of the list. That's so you can actually undo. Yeah, so let's try that. That's kind of cool actually. So if we do fruit dot reverse and then print it, so we get it in reverse order. Yeah, I didn't permanently sort it, so I was just using the sorted method. But so now if we wanted to reverse it from that, or reverse it back basically, you just run the same command again, I guess, and then it reverses it back to where it was. It's kind of interesting. And yeah, and then finally I think we can delete different fruits from the list. So if you know what index you're looking for, so in this case we'll just delete the oranges, and if we print that again, oranges are gone. If you want to use the pop value after removing it from a list, oh wait, so if you use the del statement, the element is deleted, so you can no longer use it. For example, if you had a list of users, you might want to delete a user. If you want to add, or if you want to use the value after removing it from a list, you can use the pop method. So if we say, I'm just gonna type test equals fruit dot pop, and then if we print test, we should get oranges. Oh, kiwi. I thought it would come up with the oranges, which was deleted from the list, but cool. Yeah, lists are pretty big and used quite a bit. As it says here, learning to use dictionaries and lists will significantly enhance your knowledge of how to use some of the features in AWS. Determining a type. We kind of ran into this when we tried to print the integer with the string. So this is, I think it kind of goes through that same thing here. Yeah, so cool. So that looks like it's it for data types. Let's move on to Python packages. A Python package is code comprising of individual components called modules that we use in our code. Packages save us from having to write every aspect of our program from scratch by allowing us to create to use other people's code. By importing packages into our program, we can use features of that package. Python has common packages that are included. Others have to be installed into virtual environments using Python Package Manager pip. To work with AWS, you'll need to install the Boto 3 package. Do that now. Okay. So I'm just gonna go ahead and exit out of here, and then if we clear and let's install Bodo 3. I should probably make a note of that. So that was data types, right? So now I need to add a new, come back to the summary later, I think. We'll say at today. So this is Python packages. Just some general notes here, like that I thought was interesting. Like this is all like pretty good knowledge to have, right? Like a Python package is code comprising of individual components called modules. I'm gonna just copy that whole thing there. I think that's just good general knowledge, right? You can see what packages you've installed at any time by typing the following. So if we, I'm just gonna clear here again and say pip freeze. Oops. So it looks like these are all the packages that came with when we installed Bodo 3. Creating a requirements.txt file. And just like as a side note, I've used other tools called like pipenv, which sort of manages all this stuff for you. Something definitely to look into, but this is more of like the traditional way of, saving the different packages in virtual environments to like a requirements.txt file. So because just kind of gives you like a point in time idea of like the different packages that were dependencies into the requirements.txt. So now basically we, if my Cloud9 IDE were to like shut down or die, or I had to come back to it or something like that, or save this into a repo, I'd just be able to pull this down and then run this pip install -r requirements.txt, and then it will know that it needs to include all of these different packages within that virtual environment. Well, that was a short section, so let's just say, let's create another section here. We'll call it functions. So a function is a name section of a program which performs a specific task. Functions add flexibility to code, like variables, because they are reusable. Which reduces the amount of code we have to write. So in this section, we will start with a simple function and then write a function which uses Amazon Translate service. Sounds cool. So lab 1. In Python, we declare a function using the syntax def function underscore name. Okay, a set of parentheses which contain parameters. So it looks like we'll create a little hello world function. So now we're actually gonna move away from the CLI and start creating some I think once I save it, it will hello work. Cool, so that's the function, and then we need to call the function with hello world with no parameters. Hello world dot py, and then if we run it, we get hello world. That's what's in here. Oh, let me get rid of this underscore, save that, and if we run it again, there's that looks better without the underscore there. This basically, yeah, shows how to run it. Congratulations, you have just written your first Python program. Cool. So yeah, I guess things to note here. This is probably good to fill in into our notes because the hash symbol is used for comments, right? Like that's good to know. The function is defined using def. The function has a name, hello world. The next line is indented to show it's inside of the function. The function is called by the last line. Let's see what happens if you omit the final, hello world. Well, nothing will happen, right? Because you're not calling the function here, so absolutely nothing will happen. And we can, like using the hashtag, we can comment that out and then rerun it, and we're not getting any output at all. Nothing is being printed because we're not calling the function. So if I remove that again and run it again, get the hello world. Returning information from a function. When a function performs some kind of activity, by default the information it remains contained within the boundary of the function. To pass information to other parts of your code, you need to use return. The value of the function returned is called the return value, and it is passed back to the line which called the function. I'm just going to copy this down. It's kind of a brain buster, I think. I guess it kind of makes sense, like if you well, let's continue on actually. So looks like they modify our hello world here to just return instead of print, right? And then okay, and then you can assign, it looks like you can assign the the function to a variable, and then you can actually just print the variable to get the returned value of hello world. So it's basically the same thing, except except we're returning something here. Did I type something wrong? Oh, I spelled return wrong, so yeah, so if you return this hello world string, we're getting basically the same output here. So lab number 2. So we're going to use Amazon Translate to translate some text from English to French. Looks like, yeah, the Bodo 3 docs are pretty nice. So definitely recommend checking these out. I think it has quite a bit of good like documentation and examples. Okay, so let's see here. You can see that it supports different methods. You can explore each of these if you wish. We're going to use the translate underscore text method. So if we look over here, translates input text. So just basically like yeah, the request syntax is as follows. Basically that's what it's looking for. So if we look at the, yeah, so that's from the docs here. You can see what parameters are required. So text, source language code, and target language code. Those are the, and you can see here it returns a data type of dictionary. So it looks similar to what we were using earlier for creating and updating the dictionaries. Okay, so all of these are type string with the exception of terminology names, which is a list containing comma separated values. Yeah, so since terminology names is not a required parameter, we don't have to use it, but I guess we'll specify all the other things. Cool, so let me just create a new file. I wish I knew how to I guess I can just save it. And then we'll call it, I'm just going to call it translate.py instead of that long name. So yeah, so first is import Bodo 3. And then we need to specify the client, Bodo 3 dot client translate So if we create a function now called translate, I can't type, text, and then I'm not going to include all the comments and stuff, but if we just say response equals client, so now we're calling the Boto3 client dot translate text, and then we open this up and say I'm gonna take this over here and say text. So these are, we're just filling in the required parameters now, right? So I am learning to code on AWS. Source language code equals English. Target language code equals French. Okay, so now it kind of goes through the different parts of the script that we just created here. We need to import the Boto3 package, which we're doing here on line 1. Second, we need to tell Python which specific service we want to use within the Boto3 package. This is done with, okay, so that's done here on line 3. Now that we've built our function and assigned values to our variables, we need to, right, yeah, so basically we've stored, stored the parameters within this response variable, and now we need to print that response, right? And then again need to call this function to actually print it. So I think, yeah, once we're done with that, we can clear and then push this up a little bit. And then, yeah, now we can run Python translate py, and we get the response in a dictionary. So the translated text is the key, and then the value, which is the value of the translated text is, I suck at French, so I'm not even, j'apprends à coder sur AWS. I don't know. The only thing I got out of this was AWS, so I don't know how to pronounce anything else in French. So it's funny too. I was stationed in Germany for 3 years, but I didn't pick up any other languages at all. Typical American, right? Yeah. So like we saw in the documentation, the return type is a dictionary. It looks very similar to what we got. So. All right, lab 3, the main function. In this section, the main function is introduced. As a beginner, you'll spend more time reviewing other people's code than writing your own. You will see the main function used and wonder what it does. The main function sets the entry point for a Python program using our previous example, this was called by the line translate text. This this always kind of gets me at, like, these are like sort of like Python, very Python specific, best practices, I think. When the code is run, the interpreter will define a special variable called, I think these are called like dunder methods or something like that. When we use import statements, we can import code from other files into our Python program. When this happens, the imported code is set to underscore underscore name, value of the module's name. By setting name to main, we can control the order in which to run the code in this file, which has the name of main rather than the code imported from another file. This avoids situations where your code could run an imported script, resulting in unwanted behavior. I'm not sure I totally understand that, but I'm gonna. Statements are covered in more detail later. That at this stage, all you need to understand is that telling the Python interpreter that if the underscore underscore name is equal to main, which relates in the code of this file, okay. The main function therefore sets the start point for our code to control the order in which the code executes. It is conventional to include all your calls to your functions within the main function. So that's kind of like similar to my like Java classes that I've, there's a main function, and that's where you sort of like the entry point for everything. So I am going to copy that. That seems like another good little nugget to have for, calling functions. So I guess if we take a look at our translate.py, maybe this is just a better way of doing it. So okay, it kind of makes sense now. Like, if we had another function under here, we would just call it within this main function basically. But we have to make sure. But I guess like this if statement is what makes sure that we are calling the main function. Like locally, I guess, rather than using the imported one, I guess. So I think it's the same way of doing it. So I think it's just yeah. So we get the same output, just probably a better way of doing it, I'm assuming. The Python interpreter created a special variable called name and assigned it to the code main. It then checked the if statement. This topic can be confusing. I'm glad they realized that. If you struggle to understand what is going on here, don't worry. You will see this used throughout the rest of the workshop. Yeah, definitely seems like a best practices type thing. So, cool. On to the next one. Arguments and parameters. Arguments are used to pass values between programs, subroutines, or functions. When an argument is used to customize a program, it is called a parameter. So I'm going to create a new notes section. Arguments and parameters. I think this is a good general knowledge thing to have. How many sections are there anyways? All right. In the function section of the workshop, we wrote a simple function to use Amazon Translate, which hard-coded values inside of the actual function. The problem with this is it's not flexible or reusable. To make our function flexible and reusable, we need to be able to pass values to the function at the same time it is called by the program. In the previous section, source language is an example of a parameter, which is something that the function needs to perform the action required. We assigned it English, which is a piece of information for the function. Cool. So yeah, basically we're going to be removing hard-coded values and instead using arguments. Nice. So removing the hard-coded values makes sense. So that's basically what we already have right here. Or that is exactly what we have right here. The first method we're going to use is called a positional argument. As the name suggests, the order that the argument is passed to the function depends on the order within the brackets of the parentheses. Amend the function so that we have some positional arguments. Okay. So now we can say, I'm actually just going to modify this existing translate.py. So we add text, source, language code. Here comes that snake case, right? Target, Okay, and then yeah, so then we can remove this hard coded, and it will get the value passed, down through the parameter instead. So this could be this will be source code language. This will be target language code. Okay, so now then when we call the function down here, this is where we pass in the values of those parameters to code in AWS. And we separate those values with commas. I think, like I said, the main advantage here is definitely making it more reusable. So if I clear and then run this again, yeah, same output. I wonder if what I'm gonna totally guess here, but Germany. I'm gonna say Germany is GE. Let's see what that does. Oh no, that's not a supported. Oh, maybe it's GR. Nope. Now I'm curious. Germany language code. DE, Deutschland. Duh. That was a bad call. DE. Should have known that. Oops. Ich lerne in AWS zu programmieren. Man, I'm terrible with languages. Oh, what about Spanish? España. I did take a Spanish class in high school, so estoy aprendiendo a codificar en el AW, or is it W? Essay? I think that's probably the closest I'll get to any other language. So anyways, moving on. Cool. By removing the hard-coded values, we can now call the function multiple times using different values. That's cool. So let's say, what if we'll leave Spanish there, but let's also add in our back, add back the French one. So we should get two outputs here, for one for French and one for Spanish, right? Yeah, cool. There's the French, and then there's Spanish. But we're calling it twice, calling this translate text twice. I guess that's a good note. So like, um, you can call the function more than once with different values rather than hard coding. Seems pretty useful. I think I might have to call it after this next one. But yeah, about halfway there, so maybe this will be part 1, and then the next 7 modules will be part 2. Okay, so in this last part here, so in this next step, we're going to replace positional arguments with keyword arguments. Keyword arguments is a name value pair that is passed to the function. Here are some of the advantages of keyword arguments. If the values passed with positional arguments are wrong, you will get an error or unexpected behavior. Keyword arguments can be passed in any order. I can kind of see that being like a good and a bad thing, but oops. Arguments advantages. When used with the star star, we can pass an arbitrary number of keyword arguments. We can reduce the number of lines in our code. That's always good. I'm just gonna make a note of these. Modifying the functions to use keyword arguments. So it looks like if we go back to our code here, make some more space. So I think we can get rid of this big line here and just say star star quargs. Oh, okay. So we can looks like we can bring this into the function. Okay, cool. So translate text. Oh, okay, and then we just pass it in the different key values instead of splitting them up. I like that. I think that's pretty clean. So source language code equals target language code equals. So this is just for French. Yeah, I like that. It's pretty it's pretty. Definitely looks cleaner for sure. So what did we do? We replaced the positional arguments with keyword arguments. This is done using the kwargs, which I think I like. I think I prefer this way out of the different ways that we're doing it, right? So leveling up from hard coding it directly and then adding positional arguments and then now adding kwargs, like this just looks better in my opinion. So it says so we can try to swap the order of the keyword arguments and see if it generates an error, which I don't think it will, but let me just. I think that's the whole point of it, right? Is that it's not supposed to care about the position of like the parameters that you're passing into the function. Yeah, so it still works. Using dictionaries as keyword arguments. Oh, that's interesting. Okay. So in this last example, we define keyword arguments using the syntax key value in dictionaries. In the dictionaries part of the workshop, we learned that dictionaries use a familiar or similar format of key value. Next, we'll modify how we can call the function, changing the syntax from key value to key value, key equals value to key colon value. Okay. So within here, we just make a variable with a dictionary of the same don't know. I don't know if I like that better or not, but let's run it again. So it still works. Still getting the same output, but I don't know if adding this Quarks dictionary is better. But I guess it's a way of like if you were to you know receive an output from another service that's already in like a dictionary format, it's easier to like use that data from there and pass it into the function that you're creating. So I don't know. We replaced the keyword arguments when we called the function with quarks. Being able to pass a dictionary of key value pairs rather than keyword pairs is useful because AWS inputs to programs often use dictionaries. Yeah, that's kind of what I thought. Like, you're more likely to see, well, obviously, like you, most of the outputs from the AWS services are these key value dictionaries rather than keyword pairs, which was in the initial Quarks demonstration, I believe. So I'm going to add that to here. Cool. All right. We have made it to module 8. But I think I'm going to call it here and then looks like we have inputs, loops, if statements, logging, errors and exceptions, persisting data, building in AWS, and cleanup, and then a congratulations. So that's probably going to be part 2. I'll just call it here. We've already went through variables, different data types, went through Python packages, functions, arguments, and parameters. So covered a lot, and then I think in the next one we'll go through and finish off the rest of them. So thanks for watching. I'll see you next